The problem we have chosen for hackathon is human speech detection using a small recorded clip. There are 3 members in our team. I am Emmanuel. I have 2 friends, Parth and then Ashish are the other 2 members. Alright, let's move on. We tried 2 concepts to find out whether a recorded segment has speech or not. The first concept that we tried was using the autocorrelation function of the test segment, and it worked. And the second thing that we tried was using a generalized Gaussian, fitting a generalized Gaussian to the PDF of the recorded segment, which unfortunately didn't work. But anyways, we'll mention that too. Alright, so this is the autocorrelation function. An autocorrelation function is nothing but expressing the current output or current observation as f of n as a product of a1 times the previous one, a2 times the 2 times ahead sample, and ak times. I mean, we are considering here ak samples. So ak would be, the k would be 50 over here. Alright. So now if you look at the autocorrelation function of speech, it has a more periodic pattern. This periodic pattern is synonymous with the vowels or voice sounds. Voice sounds basically like a, e, I, o, u, all these voice sounds have this periodic kind of pattern. On the other hand, if I am using yes or that's just the unvoiced sounds, is not going to give this pattern, but most of all the words will be understandable only with the voice sound. So with the voice sound we get a really beautiful periodic pattern. Now if you look at acoustic sounds like clapping and other sounds, you see the ACF function. The ACF is going to have just one zero crossing. Now if you look back, if you look back at the speech signal, in the speech there are multiple zero crossings, correct? So now if you look at the number of zero crossing in case of acoustics like clapping and other noises, you get just around 1 zero crossing, and ACF is something like this. Now if you, this is the ringtone of a mobile, so the mobile ringtone has like lots of zero crossings. That is because all the beats are sharp and it dies down immediately, like ping 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 ping, so it just dies down quite fast. So though there will be a lot of zero crossings over here because it's not that correlated with the past. Now if this is silent and nothing was there, just there was an AC noise going on behind, so air conditioner noise had some correlation like something like this. So this is for silence. Now we also looked into the second parameter that we saw was the variance. So variance corresponds to the amount of power in the segment. So when there was any speech present, the variance was between 0.05 to 0.4, whereas when there is silence, there is pure silence or probably noise, the variance was 0.05, and when there were some acoustic sounds like clapping or some drums or something like that, then acoustic sound, the variance was again between 0.5 to 0.4. Now if you look at it using just variance, I cannot distinguish acoustic sounds and speech, so I'll be able to distinguish if I am using the number of zero crossings in the autocorrelation function. So in order to detect the speech, there are 2 things that I consider. First thing is the variance of the recorded sequence was between 0.5 and 0.4 for speech, and then the number of zero crossings in the autocorrelation function, observed autocorrelation function, is between 4 to 12. Alright, so this is the other method that we tried, which unfortunately failed, but it was anyways good enough to mention. Now you have a stochastic speech could be taken as a stochastic sequence. Any stochastic sequence can be associated with a PDF. So the PDF we associated it with a generalized Gaussian PDF. So using a maximum likelihood method, we fitted the shape and the variance. I mean, the generalized Gaussian has one difference with the normal Gaussian in it that instead of just having mean and variance, it also has a shape parameter associated with it. So based upon the shape, it can approximate either a Laplacian PDF or an uniform PDF. So Laplacian corresponds to an alpha of 0.5 over here, and then a uniform PDF would correspond to alpha of infinity. Alpha and alpha tends to infinity, it will be that. But anyways, that's a broken method. But that's it. Thank you for listening.